If I asked you what was one common attribute amongst these 5 Yonko, not being their high bounty, would you be able to tell me that it's their blood type? Or if I asked you who the oldest character with a bounty is, would Morley be your answer? And on the flip side, if I asked you who the youngest character with a bounty is, would you know that it's Drew Bonnie? If you're interested in insights such as those, I recommend you check out my previous video, One Piece Bounty Analysis Part 1, where we employ exploratory data analysis on all the characters with One Piece bounties. I also recommend that you hit the like button and subscribe for more future One Piece Analytics videos. Hey YouTube, welcome back to the channel. It's your boy Taicho, and that's X. And today we're continuing our analysis of One Piece character bounties. As mentioned in our prior video, we did some really cool exploratory data analysis and uncovered some interesting insights regarding the characters that have bounties in One Piece. In this video, we're going to kind of step up our level of sophistication, and as an extension of our exploratory data analysis, we're going to employ unsupervised machine learning techniques to see if we can uncover any groupings or patterns within our data set. What exactly does that mean? Well, X, first, if I can ask you to develop a Python script for k-means clustering, that'd be great. Nice. So X has provided us the script for an algorithm known as k-means clustering. What the k-means clustering algorithm enables us to do is take our data, which has no groupings established, and create groups out of that data set. How the algorithm is able to do this is by using numerical variables such as age, height, number of chapters a character has appeared in, the most frequent chapter a character has appeared in, the initial chapter that character appeared in, and lastly that character's bounty. Using these numerical variables, the algorithm created by X will identify characters that have very similar attributes and put them in a group, but will also make sure that the characters in that group are as different as possible from characters in other groups. Essentially, these groupings, we as One Piece content consumers and members of the community can then create labels for these particular groups and review the labels to see if they make sense. And that's exactly what we're going to do in this video. So the steps for this are first going to be briefly taking a look at the data and the algorithm that X has created for us. Then from there, we're going to review the 5 outputs, or the 5 distinct groupings the algorithm has decided is most appropriate. And then lastly, we'll jump into a dashboard so that we can visualize and digest the information a little bit more easier, and also determine whether or not the groupings make sense from a content perspective. So without further ado, let's jump into it. Okay, so the first part of this analysis, we're going to review the data and the algorithm output. Here in the script, you can see the first main thing is to kind of import the packages that we're going to be using for this clustering algorithm, and most of that's going to come from scikit-learn, which houses a lot of Python's machine learning algorithms. If you're interested in all the pre-processing that I did prior, you can check out the One Piece Data Analysis Part 1. But essentially, we import these packages and we want to make sure that we're working with purely numerical variables. So here we can see that we have the age, the chapter appearance, the number of chapter appearances, the max chapter appearances, the bounty, and the height that that character is. So that's the data that we're going to input into our algorithm. And then the next part, which is really the key part when you're using an unsupervised machine learning algorithm based off of distance metrics such as decay means is to standardize the data. What standardizing the data essentially does is take the wide range of the wide range of data that we have and condenses it to a much shorter range. This is really important because when we're determining groups within our data, if there are variables that are essentially outliers and lie on the extreme end of a range, such as the height of Orange Jr. or the bounty of Roger versus the height of Julie Bonnie and the bounty of a character like Chopper, it's going to throw off all the distance metrics because the ranges is just too extreme. And so what the standardizing does, by shrinking it, it essentially says how different is this character's metric from the average of these metrics within the data set. And in that way, the algorithm is more easily able to identify who should go into certain groups based off of how different they are from the typical data point for that attribute. And so here we have the standardized data. Usually what this falls into in terms of number ranges is like -3 to 3, with 0 being the mean or the average. Next important step is to determine how many groups is appropriate for our data set. So is it 2 groups, 3 groups, 4 groups, 5 groups? We don't know. One simple technique is called the elbow method, and what the elbow method does is use a metric called sum of squared errors, which essentially looks at the data points and sees how close they are to the center of a particular group, and then kind of stores that number and compares it against the same number for different numbers of groups. So for 2 groups, it'll look at what the sum of squared error is for the characters in those 2 groups, and then it'll compare it to 3 groups, 4 groups, 5 groups, 6 groups. Essentially, we want a lower number because that means that these groups are more tightly associated. However, we don't want to have too many groups, say 1,000 groups, because basically that would just be non-beneficial for us. So we choose what is known as the kind of bend point, and that's why they call it the elbow. So where does the bend happen? And in this visual, we can see that at 5 clusters, I would say this line bends, and so we should use 5 as the number of groups that we want to create. And so we do so. We initialize our algorithm using this quick script, and basically what it does is applies a cluster ID to each of the characters. Those cluster IDs are going to be 0, 1, 2, 3, and 4. If you're not familiar with Python, the first number that Python uses is 0, and so that's why it's 0 to 4, giving us 5 groups. Not going to go over the centroids because we'll look at that kind of information from a visual perspective, which will make it easier to digest. But here you go. We can kind of see what that data set looks like. All the various attributes and the characters' cluster ID associated with them. Then, because the cluster IDs aren't really kind of, they have no one-piece content value, what I've done is, after kind of analyzing the data, I've assigned each of the cluster groups what I think is a relevant title. And this is where, if you remember earlier in the video, I said we don't have any labels for our data. these groups become our labels. And so I've essentially labeled the groups based off the characters within those groups. So the 5 groups that we have is, first starting with group 0, is the elite class. The elite class will consist of characters with relatively high bounties and are pretty prominent figures in the story, but they're not exactly on that upper echelon of the most elite characters, and they don't all necessarily appear the most frequently as it relates to other characters like the main characters. Speaking of main characters, that's going to be group number 1. So when you think of main characters, I'm sure all the Straw Hats kind of come to mind. That's going to be group 1. Then we have group 2. I'm calling these the top tiers. This is going to be the cream of the crop as it relates to One Piece characters, and I'm sure different story labels already come to mind, probably thinking about Yonko or Shichibukai. And then we have Big Man. We'll see who that is, because it's only one character. And then lastly we have the group called Notable Moments. I labeled this group Notable Moments because these are characters whose bounty aren't exactly the highest. They don't appear in the story super frequently like the main characters. From a power scaling perspective, they're probably not the strongest, but these characters do have bounties and they do have moments which are pretty notable within the story when they happened, and so that's why I called them Notable Moments. And so bam, without giving you the character names, you can kind of see what that final data set looks like, with the cluster name and the cluster ID associated with them, as well as some bounties, all the other attributes. Okay, so now that we've gone over the data and the algorithm, it's time to jump into the dashboard and see if the labels that we created or the labels that were created from the algorithm actually make sense. Let's check it out. Okay, now that we've gone over the algorithm and the data and how that all kind of gets outputted into our 5 different segments, it's time to see if those segments make sense using our dashboard that I've created in Power BI. Admittedly, I kind of held on to this video because I wasn't super happy with how this all came out. Power BI is not my favorite, and this is probably going to be the last video I use Power BI before I transition over to Tableau, where I'm much more comfortable. However, we have the dashboard, so let's go and jump right into it. So quickly, let's break it down. What do we have here? We have 3 distinct sections. Our first part is going to give us kind of some high-level counts. We have a donut chart of the clusters and how many characters are in them, followed by a bar chart of the number of characters by blood type. We had a similar visual in our One Piece Bounty Part 1 video. And then from there we have the average height of the characters within the different clusters. And you can clearly see Big Man being by far the largest character there. In this middle part, I tried to put this Q&A section. We'll play around with that and see how that works. And then on the bottom, we have a scatter plot which shows the average age of the cluster by the average bounty, and the size denotes the number of characters that are in that cluster. So starting from the right, you can see we have the smallest one, Big Man, over here, being probably the oldest in terms of average age. We have the top tiers, this group clearly having the highest average bounty amongst the different characters, and while having the second highest average age. So these are going to be older gen characters with high bounties. In the middle, we have the elite class. This has the most characters. While it doesn't have the highest average bounty, it's kind of in that middle section again. Really only being beat out by the top tiers and the main characters, which is over here. And then right here we have the kind of notable moments. So these are characters, as I mentioned, that have lower bounties, most likely appeared earlier in the story, because as we progress throughout the story, with bounties that are introduced just organically have higher bounties. But these characters had notable moments and they still have a bounty, so we gotta put them somewhere. And then finally, what we have here is a table with information on those characters, right? So you can see right off the bat, if we're ordered by bounty, who the top tiers are. I think that makes a lot of sense. And then scrolling down, we kind of see a mix of different characters, many of them being either the main characters or the elite class. We have some, the sum of the bounty, the blood type, where they're from, their cluster name, their status, their age, and how many chapters they've appeared in. Cool, so now that we have like a breakout of the dashboard, let's click around, use some of the interactive features of it, and make our final determination on whether or not the cluster names make sense. Alright, so I'm going to start with the pie chart and just go through each different visual. So let's click on elite class. So clicking on elite class, we can see that, many different blood types, so there's no dominant blood type here. The average height of the characters in the elite class is 11 feet. One Piece characters, by nature, just have absurd heights. Average age, a little bit less than 40, so 39 years. And the average bounty, 306,000. And there's 82 characters, so would I classify 82 characters in the elite class? That's debatable how you want to look at power scaling. Keep in mind we are only looking at pirates, so this doesn't include any marines, so no vice admirals and such, only characters with bounties. Let's actually go through and determine whether or not we think they're elite. So this elite class has Boa Hancock with the highest bounty, 1.65 billion. I think that is the highest out of all the first Yonko commanders that have been revealed, so I would definitely put her in the elite class. We're talking about an individual who has displayed great feats with her devil fruit. Pretty much any character below admiral level that's not Shichibukai, she can effectively take out with her devil fruit. She has all hockey abilities, conquerors included, so I would definitely say that Boa Hancock goes in this elite class. She appears in a decent amount of chapters, and she's a 31-year-old individual. I would swipe right. From there, we have King, so he's going to be our first Yonko commander. Then we have Marco, Queen, and interestingly, we have Jinbei. So, before I touch on Jinbei, let's look at some other characters. This group, you can see, right off the bat, is really the Yonko commanders, other executives, some Shichibukai, and then some other interesting characters like Jinbei and Brook. So I would think that this is a relatively representative name. Maybe elite is too overrates some of the characters, like I think it's fair because most of these characters, outside of like Alvida, Gali, maybe like Panda Ban, most of these characters are going to take out anyone that's below an admiral level, right? We're talking about Yonko commanders, executives in Yonko's crews, crew leaders like Doflamingo, top tiers like Ulti, and then we have two of the Straw Hat characters. So interestingly enough, Jinbei didn't make it into the main character list, and neither did Brook. So if we look at Jinbei, right, he has the same blood type as Luffy, being F. He has a 1.1 billion bounty, deservedly so. But I think some of the reasons he's not in the main character grouping is he hasn't appeared in as many chapters as most of the Straw Hat crew has appeared in. And he's also older, right? So some of the defining attributes of the main Straw Hat crew is they're younger, very high bounty, and they appear in almost every single chapter. So those variables probably distinguish Jinbei being more similar to these elite class rather than the other ones, and he was also the last Straw Hat to appear in the story, meaning his first appearance. And it's, Jinbei didn't appear until Marineford, so I think based off of a data perspective, it makes sense from a story context. He definitely has more impact, and he's probably the highest appear. No, he's not even the highest appearing one. So we have Brook. Sorry. So Brook and Jinbei. Everything I just said for Jinbei, I think also applies for Brook, right? We're talking about high age, appeared later in the story, and for Brook, his bounty isn't really on par with some of the higher Straw Hats. Talking Sanji, Jinbei, Zoro, Luffy, even Robin. And then these other variables, he's just too different from the Straw Hats to be put in that group. But all being said, I think that this list is this grouping is pretty accurate, and I would agree. If you want to change elite to like top officer, be my guest. Now let's go to notable mentions. Okay, so resorting by bounty. So for notable mentions, right off the bat we have Fisher Tiger and we have Squard. Talking about those two characters in particular, I think when I was coming up with the name for this group, these characters kind of defined it for me. So Fisher Tiger, having the highest bounty in this group, obviously doesn't appear in many chapters. He's older than the main characters, not the highest bounty, so he's not going to go in the elite class. He's not going to go in a top tier class. He's not a main character. He has a bounty and he has a notable moment, right? We think of him, one, starting the Sun Pirates, and we also think, of course, of his breachment of Marijois and freeing all the slaves, right? Those are kind of the key moments that we think of Fisher Tiger, and we don't really have that many other moments to think of because he didn't appear in many chapters. So that's probably a defining attribute, right? A lot of these characters have lower bounties and don't appear in many chapters, so those two metrics are probably the defining attributes of this group. And we have an array of different ages, but they're not so different that they could go into an old group defined only by age. Other characters, we have Bellamy, notable moment, getting, punched by Luffy. Two different instances, one shot punched, ending his life. Caribou's an interesting character to be in this list. He hasn't had quite that notable moment, but he's had some weird moments. His bounty is just not high enough, nor is his character appearance high enough to put him anywhere else. That's why he's kind of grouped into this, but I would say his most recent character appearance, if you're familiar with, it's a pretty notable moment. Finally, we were informed that he wants to tell Blackbeard the whereabouts of two of the ancient weapons. That's going to be his main notable moment. How Blackbeard treats him afterwards, TBD. Probably won't go well, but we'll see. And then we have a bunch of other kind of characters that outside of Foxy, Arline, Krieg, Jin, Hachin, I can't really remember some of these characters, so maybe I should just rename this instead of notable moments to something else. Let me know what you guys think below. Then we go to top tiers. I think this is probably the second most definitive, right? So interestingly, with the top tiers, and as I mentioned in my prior video, a lot of really strong characters have like the blood type F. I don't know what it is, but Oda seems to use this for commonality amongst many top tier characters. Alright, so we have Gold Roger, Whitebeard, Kaido, all the previous Yonko, the Pirate King, current Yonko outside of Luffy, and then we have Mihawk, obviously a top tier, Yonko level of course, followed by some up-and-comers. So here is where the main debate would happen. Buggy gets into this list because he has a very high bounty. I'm surprised if Buggy had appeared in more chapters, he would probably be in the main character list. He just doesn't have enough to get into that, and he's also older than the main character, so his age is more closely related to some of these other characters. He's right around 40, which is Shanks, Mihawk, Blackbeard, Crocodile. They all share that kind of like middle-aged man. He has the high bounty because he's a Yonko, but yeah, he debatable. But you gotta put him in the top tier. He's a Yonko for a reason. He has the status, so I think it's appropriate. Then we have Eustace Kid and Law. I would say that these characters, because of the events of Wano, separate themselves from those in the elite class. I would also think that in a one-on-one, these two characters would probably take anybody in the elite class. Their bounty, of course, is what puts them here. So high bounty, lesser chapter appearance than the Straw Hats. Similar age though, but I think because they have lower chapter appearances, they're not fitting that Straw Hat or that main character list as the others. And then we have Crocodile. I would also think he's an elite. He could go either way. Whether or not he's where do you think Crocodile more fits? Does he fit in the top tier or does he fit in the elite class more? His is a little bit more debatable. I think one common attribute Crocodile has with these characters, outside of, while he has the lowest bounty of this, he appeared pretty early in the story, so characters like Gold Roger, Shanks, Blackbeard, Mihawk, Buggy, they all appeared relatively earlier in the story, in the first 25%. And Crocodile's age is pretty similar here. So that's my guessing, but I think just by order of bounty, he could go either way, whether he's a top tier or elite, but TBD. He's got the bounty buff now. We'll see what the Cross Guild is made of, I'm sure, in time to come, and see what Crocodile's got. Then we have the main characters. So this is the Straw Hat crew outside of Jinbei and Brook. We've already discussed essentially why. The young age, I think, this is Robin, I believe. Yeah. Oh no, that's Frankie. So Frankie and Robin being the two oldest ones. I think the age, the predominantly young age, the high volume of chapters, appearances, and then those two is the probably key top two metrics I would say that define this group, followed by bounty. Chopper being the only outlier in terms of his bounty, which is hilarious, but no other character comes close to 616 chapter appearances. So this is kind of like a very heavy weight for this group. Oops. And then lastly we have Big Man. So Big Man being Little Oars Jr. Little Oars Jr. has his own group because his height is just so drastically different than all the other characters that the algorithm just saw him as such an outlier, had to put him by himself. I forget how tall he was, but 197 feet, just dominating any other character. Relatively respectable bounty. Doesn't appear in a lot of chapters though. But yeah, that's Big Man.